Okay, so this is a notebook that we have from yesterday. I just made a copy, and today we're gonna pick up from where we left off. And the date is 27. All right, so really quick, I'm gonna run through these libraries, but I wanna make sure that I don't go crazy with the EPUB, so we don't wait a lot of time. So first section is regression. So I'll put my cursor here, and the trick is I'm gonna go to runtime, and I'm gonna click run before, and that will run everything before. Oh, of course, I have a problem here. This is a problem when I don't have a correct directory. So what I need to do is click these three dots, and I get a path, and I paste the path here. Same with the test set. This will give me a clean slate. All right, awesome. And then I scroll down here, I put my cursor here, and then I run before. All right, there we go. Okay, so while this is running, and I'm gonna try to do a little bit Q&A. Okay, so somebody asked me a question about exactly what does it mean when you make a classification question or when you do a classification task, such that the last layer it's like more than one neuron. So specifically, we've seen a couple of situations here. Let me just run through this rest of the code. And then if you look at the model, here we have last layer that's 10 neurons. Here we have last layer that's also 10 neurons because we're making a classification problem. So really what's happening here is this. I'll draw it out and then I'll write out in mathematical functions. So imagine you have your data, right? That's maybe, let's say this is your pictures. You come in to your model. Right now, you can kind of think of it as a black box model, which is going to call that f of x. And then you're making some sort of outcome, right? So this is a standard pipeline that we have. Now, here's a problem. What if you have a neural network, right? Neural network means what? Means you have layers, and every layer you have neurons, right? So instead of having this f of x, now you dig into the f of x, you break it apart. Now you're supposed to draw things this way. So you have all these neurons, they're connected, and then same thing here, and so on and so forth. But here's a caveat. If you are doing a regression problem, then here you just need to have one neuron. Then the reason is because you are predicting one number. And whatever this is, it's a number, okay? So in simple terms, you can kind of think of it as x1, x2. You have a connection here, you have a connection here, and then you have a number. So maybe this is W1, this is W2, and then they're linearly additive, right? So they're x1, W1 plus x2, W2. So whatever this is, it's a number. It's a numerical number such as 1, 2, 3, 0.5, 0.2. It can be also negative, right? Minus 5, something like that. Now, of course, we have activation function. We take care of that if we want to make a probability. So all of things, you can do it. It's all engineering. You come back, you take care of it, depending on the assumption of your data. But the big picture is, well, you have these links, and end of the day, you have one number coming out. And that's exactly what it is. And this is a regression problem. So then the idea is, okay, how do we turn this into a classification problem? So in order to do that, let me give myself some space. In order to do that, you need to have essentially the information coming and you go to the same model. But let's say it's a 2-class, right? 2-class, it's a kind of like a special case because what that means, it's 2 neurons. Now, think about intrinsically what it means in reality. If I tell you it's a picture and the picture is either cat or dogs, then what that means is this data is not any data in the world, right? It's not any picture of any animal in the world. It's the particular set of pictures that it can only be cats or dogs. Okay, so unfortunately, that kind of assumption will turn this classification result almost nearly identical as what you're doing here. So these are almost nearly identical. Because think about it, if this number is large, it's a large number, let's say a large number, then you translate through 2 neurons. It could very well be this is a large number. And if that's a large number, then this is guaranteed to be a small number. Okay? Simply because it's either cats or dogs. It's intrinsically what the data assumes. It's the assumption. So because of that, if you have two neurons, then you're kind of like, well, what's the point of that, right? Then you might as well just do this one. It's true. Turns out the answer is true. If you only have two class and you want to do things this way, that's not a problem at all. You're going to get a job done. The code will run. You're going to have good results. And you should get almost nearly identical results as if you're doing two neurons. Does that kind of make sense? So that's kind of like one of the big questions. Let's see. Sam says he will be back shortly. All right, good. Okay, so that's kind of like the difference between one neuron and two neurons. Okay, so it is a small difference, right? It doesn't change your performance a whole lot. And as a matter of fact, it shouldn't, right? Because if you're a large number here, it translates to one of these neurons to have large number. And since they're binary, which means they're complement of each other, right? You're either A or B, right? You're either cats or dogs. Then if you're not cat, chances are you're dog, because that's the only two options that you are allowed to take in this data set. So that's kind of what's going on between 1 and 2. Now you might ask, okay, what if I have 3? What if I have 4, 5, 6, 7, 8, and so on and so forth, right? Whatever large number that I have. So you cannot do all of that, right? In higher dimension, you can have data coming in, and then you can say, okay, I go through all my work, I write all of those code, and then maybe I have 10 classes. That's fine. Or you can have 100 classes. That's also fine. You can have as many classes as you want. As long as you have the data, you have the bandwidth of the computer to make that computation happen, then you feel free to do however many classes you want. It's a subjective choice by yourself, right? So here, maybe you have 1, 2, all the way to 10. That's fine. Or you can say, I'm going to do 100. That's also fine. You just need to provide that data. And if you have the data, you can train however many classes that you want to. Okay? So that's one thing I want to tell you guys. The only tweak in these models, when you go up in terms of number of classes, is the activation function. That's about the only tweak that you have to realize to do. And it's kind of like the bare minimum, right? You have to do that. On top of that, of course, you can do whatever you want, but that's not a must. So when you go from the first model to the second, or to whatever you want down here, the tweak that you have to do is a softmax function, right? And I'm going to explain what that is. So softmax function is essentially what's going on inside of these things here. Let me switch different colors. So it's what's going on inside of this. Okay, it's what's going on inside of this. And I'll show you guys just using math what that means. Let's say I'll write it here. I'm going to write the math first, and then I'll show you guys what it means. Maybe I should write it next to the softmax here. I'll write it here. So softmax function is a type of activation function that is for classification task. Okay, so the function is defined as, I'm going to use latex to write out a math equation. So I'm going to say softmax, and it's defined by some sort of x, but in this case, it's with regard to a particular class, right? So it's some sort of a subindex k, if I will. It looks something like that. So subindex, it's an x subindex k. And what that means is, okay, what is defined? It is defined as a fraction, okay? So you write a fraction. The top of the fraction is going to be some sort of exponential term with x k. So maybe I should use a different letter because the k, let me use a different letter just so people don't get confused. Because x is technically speaking referring to the original features in the data. I want to separate that a little bit, right? This is the last layer, right? So if you go through all that hidden layers, chances are it's going to be something else. It's not going to be the original x. So let me just clarify that just a little bit, and I'm going to use a different letter Z, okay? And you guys will be able to see here from the mathematical equation rendered on the right-hand side. So I'm going to say exponential Z, obviously with a minus sign, and then here we're going to say summation. This is sub k, and then minus Z k. Now notice that this is with respect to a particular class, right? So I better say something unique about this k. So I'm going to say k star. Star. Oops. Star. There you go. Okay, and same with this. This is going to be k star. Right. So once I write it out, I am missing something down here in the bottom of fraction. This should be exponential. All right, there we go. Okay, so that's the equation. Now I'm going to demonstrate how that works, right? So an exponential term is just you take an exponential, right? It'd be as if you do you can do there's so many ways to do this. So np dot x exp, that should be able to give you something, right? So you need to throw in something. Let's say 2, right? So it's about 7.38, right? And you can verify this because the exponential is about 2.7, right? And then if you take a square, so that's about 7.3, right? So that's how it works. So this function basically just take e, the exponential e, right? The Euler's number e, to a power of something, right? So that's what's happening. Now think about this way, right? So we have the math here, and we can do whatever we want, right? So now think about this way. In this formula, let's use a different example. Let's say I go through my neural network, and it's 3 class. Not 1 class, not 2 class, it's 3 class, okay? So we say, suppose our neural network model produces 3 classes in the end of the model architecture. This means what? This means it gives you 3 numbers, right? 3 neurons, of course, it gives you 3 numbers, right? That's what neurons means. So hence, we have 3 numbers that are real numbers. So depending on what kind of softmax function you do, and here we're going to explain that how the softmax activation function works. But before we apply an activation function, it's just the original number coming from a linear regression model, right? So it can be positive, it can be negative, it can be whatever it wants. So these 3 numbers are in a real set. Real set means from minus infinity to positive infinity, okay? So we can say that belong to real set. A real set in, when you guys go to the undergrad and take this math course called the real analysis, it's indicated by this boldface R. That means real set, okay? So what would that look like? I'm gonna, again, use latex to draw out. I'm gonna write a B matrix, that means bracket matrix. Right, so I'm gonna give out 3 random numbers, right? Let's say 4, 10, minus 5, right? 3 random numbers. You have 3 neurons, you do all your math, and the model says the output is 4, 10, minus 5, right? As simple as that. So then you say, okay, let me send that into a softmax function. So arrow, and then you say softmax. Of course, it's a function, so it's a parenthesis, right? And in the parenthesis, you send this matrix in it, right? So you do something like this. Does that make sense? And then this needs to come out and spit out some sort of probability distribution, okay? And the reason that's the case is because we want something to tell us that, hey, you give me this data and I work out my math, I work out my model, it is certain percentage of class 1 and certain percentage of class 2 and certain percentage of class 3. And whatever that's the highest percentage, that's the class. That's the class this thing belongs to, right? So let's try that. Well, we have the model, right? That's the math, right? So the rest of the thing, you just work out the math. So let me write it down here. We're gonna say, in this case, you can probably just get away with a P matrix. It means parentheses. So P matrix. And of course, the first thing is going to be some sort of output. So we're gonna say we're gonna throw 4 into the softmax function, but we're gonna follow exactly that formula. Okay. So bear with me. I'm gonna write it out. It's going to be a fraction, right? It's going to be a fraction of something divided by something plus something plus something. Right? Think about it. What is a summation? Summation K has what? 3 classes, right? So if I want to write it out, it should be something like this. If I have a summation and the K is from 1 to 3, why 3? Well, you have 3 class, right? So that's why this is 3. So 3 of something that's sub-index K. So what does this mean? This means something 1 plus something 2 plus something 3. So that's what the symbol means. You expand it, the K can be 1, 2, all the way up to 3. All right? So we're going to do that, right? That is the bottom of the fraction. That's why here I wrote A plus B plus C. Just means I have 3 things add together. Okay? So you can kind of guess, oh, okay, so then the next number is going to be what? B over A plus B plus C. And the next number is C over A plus B plus C, right? So let's write that down. Following this definition, what do we have for the next one? The next one is going to be B over the exact same bottom, right? A plus B plus C. And then same with the last one, right? Fraction C over A plus B plus C. There. Okay, so now we have all of the formulas, right? This formula is exactly what's happening here. The only thing I haven't write down is the exponential term, but that's okay, we're gonna do that. So what is the exponential of what? Of 4. We're gonna write it out, right? So we say np dot exponential 4, np dot exponential 10, np dot exponential minus 5. And we run it. It will give us these 3 numbers, right? It doesn't matter what they are. They should be proportionally large or small as their original input. If this 10 is the largest, it should come out as the largest number, because exponential it's not an inverse formula, right? If you go up, you go up, right? It's the same direction. So if I can convince you this way, maybe that's easier. So y equals to exponential some sort of x, right? It's like one direction. It's not going to go down, right? It's one direction. If this x is larger, then the y is going to be larger, right? It's just larger at the higher rate, right? That's what exponential means. It go up. So because of this mathematical definition, if your output neuron is a larger number, and when you transform that into a probability, it will be even larger. So it kind of mathematically magnifies the probability proportion according to the original numerical number, right? And we're going to see how that works, right? So 10, once you take the exponential, it becomes 22,000. 4, right? The first number 4, you take exponential, it's only 54. And then you look at this one. This one is a minus 5, right? So it's technically speaking negative. So it's kind of like if you take something to the power of negative, then you're kind of like dividing it, right? It's the inverse. So then that becomes what? Exponentially smaller, right? So if you stay in the middle, nothing happens. If you go up, if you're a large number, you exponentially increase. And if you're a small number, then you decrease. Okay, so that's what's happening. And then you take a look at the bottom, it's 3 numbers add together, right? So we need to do that. So we write these 3 numbers, and then we're going to add them together. I'm going to cheat a little bit. I'm going to say np.sum, and then I'm going to throw them in here. So this 22,000 is going to be 3 numbers add together. All right. So now we have our numbers, right? We have all of the numbers. So let's write that down. All right. So this equal I'll just copy this down because that's essentially what we are doing. Right, so A, what is A? A is 54, right? B is 22,026, right? C is 0.0067, right? And then what is A plus B plus C? It's this number here, right? So I just grab this number and then I copy that and I put it here. And then I put it here, that's the second line. And I put it here, that's the third line. Right? So that's the output, right? So now you realize something. If I add them together, it has to be what? It has to be 100%, right? Because the bottom of fraction is exactly the three numbers add together, right? So, you know, I can probably write it out. A plus B plus C plus B, A plus B plus C plus C over A plus B plus C. This has to be 1, right? It's 100%, okay? So basically what that means is this 4, 10, and 5 now translates to a probability distribution that has to sum up to be 100%. So then it makes my life easier, right? I can say, oh yeah, the probability that this picture, right, or whatever, this X, whatever data that you're looking at, is the second class, it's a high probability. And as a matter of fact, I can tell you exactly how high that is, right? You just do your math. You say, hey, what I'm going to do is I'm going to open up a new block, and then I'm going to take these three numbers, and maybe I can just do a division, something like that. Let's see. I'm not sure if this works, so let's try it. Okay, so it works, right? So whatever that is, right? So now we can write that down. So this is going to give us a matrix of probabilities. First number being, I'm not going to spell it out because it's like minus -3. So I'm just going to take these three numbers and then I'm going to put it here. All right, comma, comma, yeah. So now you kind of get it, right? It's kind of like a probability. Why do I say that? Well, the first number is kind of like almost too small, right? 0.000247, something like that, right? So 0.002, yeah, 47, something like that. That is basically how big it is. You can kind of think of this as 0.2%, right? 1, 2. So it's about 0.2%, something like that. And then what's the second number? Second number is 9.975. So this is like 99.75%, right? So 99.75%. And then the last one is like 0.00000 to almost like 7th digit. So I'm not gonna write that out. So I'm just gonna say 0.000 and almost like near 0. So something like this, almost 0, right? And then you can kind of get the idea. They add up together to be 100%. Here I have a little rounding issue. I didn't round it correctly. But if you round it, this 47, so you can probably round to 2.5. Yeah, so 0.25. So you say 5. And now add up to what? 100%, right? So that's kind of the idea. So in other words, I didn't look at 4, 10, and -5. What I'm looking at is this probability. Now it makes my life easier. What class is it? Oh, yeah, the second class, right? Now I can tell you, hey, this is, oops, this is the second class because the probability towards the second class is the highest. That's it. It's as simple as that, right? So how do I know second class? Simple. I go through this math, I do my softmax function, the second number is the highest probability. That's how I know, right? It's exactly like that. So this is why we want to put softmax here, all right? So I just gone through all that trouble just to explain what this one word means, okay? Now you kind of get the idea, right? You know, 10 neurons. 10 neurons means what? Means you have 10 of these numbers, right? Because there are 10 classes. And then it better be the case that all 10 classes sum up to be 100%. Because it's not 100%, then obviously something's wrong, right? So this is, of course, this is only the case when you do classification problem. If your data is a regression problem, then you need to go back up to this model up here that we use for regression problem, which is here. Then you see that we don't really have softmax, right? Because we don't want a probability. But whatever it is you predict, that's whatever it is you predict, right? So we don't really need the probability. So this is kind of the difference, right? So how do I know to use softmax? Well, you look at data. If the data you want to produce or the data you want to investigate is a continuous variable, then you do regression. If the data you want to predict, it's a classes, right? Remember the ratings of the movie stars, right? If I give a movie 5 stars and Sam give a movie 2 stars, it doesn't matter. It doesn't mean I like the movie 5/2 times as what Sam likes, right? It doesn't mean that. So that's the difference. If you feel like you're doing classification problem, now of course you need to go down here and then you need to do this. Okay, so it's kind of like as of this point, you can kind of say that softmax is kind of like a must for you to move away from regression and do classification. There are some activation functions that's kind of like optional. If you don't do it, no one's gonna say anything about it. But if you're in a classification setup and you know that what you predict is classification problem, and you still don't use softmax, then something's gonna go wrong. Okay, so I just want to lay that out there. You're probably gonna get a code to run. It won't be accurate. Okay, so I know I say a lot of things such as trial and error. It's completely up to you. You have a lot of freedom to do so. I know I say a lot of that, but this is one of the cases that it's not that. If you want to do classification, you better use softmax. Otherwise, something's gonna go wrong. Okay. So I just want to mention this because somebody asked a question. Let me know if this is still clear. Let's see. Okay. So yeah. So somebody asked a question. Does Z mean the output of X after it goes through the function? Yes. So these Z letters here, it means whatever's going inside of the last layer. So think about this way. If you have a bunch of neurons, and then this is your X going in here, and then it doesn't matter how many layers you have. You could have more than one layer, right? And then you have some sort of output. The Z, right, these Z letters, it means whatever's coming out of this last arrow that goes inside of these neurons in the last layer. So the input here is Z. Like these guys are Z. And the circle means a function. Okay, the circle means a function. In this case, it's a softmax function. So that's why the input of the circle is the Z. K is tracking the class. So Z sub K, yeah. So the K is tracking the class. If you have 3 classes, then this is Z1, Z2, and Z3. And the number 3 is kind of like an example I made up. If you are doing 10 class, then you have to do all the way to Z10. So that's what K means, and that's what Z means. And another question says, the softmax function will give you the percentage that each of the class takes up the total set of real numbers. Yes, it will give you the percentage. It doesn't. It's not a direct translate of real. I guess it is. But you have to make sure that you take the exponential increase and decrease into effect, because that's what the exponential function is doing. So it's not just a direct scale up or scale down. It's scale up exponentially. Yeah. So that's 2 questions that's being asked in a Zoom chat. All right. Okay. So another question. Can I reverse the model such that input a number and then it returns image which follows the style of training images? If so, which model is suitable? Yes, you can. That is called a generalized adversarial network. So the second question, it's basically like this. So what that means is you need to have a model that here I'll show you. Let's look at this, right? So this number is what I define myself, right? It's not written in Bible. It's not written by some scientist, right? I define myself, right? And as a matter of fact, I can challenge this to 128. It doesn't have to be 128, okay? So what that means is if I can probably change these numbers and make them go smaller. So I can do something like this. And then here, maybe I become 16. And here, maybe I become 32. And then here, I become like 64. And then here, maybe it's like 128, right? And then here, I'm going to recover the original dimension with 784. So you can do this and it will work. So this is called an autoencoder. And there's another step to get to what the question is suggesting. So bear with me. So what's happening here, right? This is called an autoencoder. Autoencoder means you shrink the dimension first, and then you increase the dimension. And this part is called the encoder, and this part is called a decoder. Okay, so you need to do this first. This is number one. Once you do this, right, and assuming that you've done all your work, the code is well written and it's well trained. If this is not accurate, then forget about next step, right? This has to be accurate first. Then you can talk about next step, which is what the question is saying. So next step, number 2. The question says, oh, can I reverse the model and input number and then return the image? So yes, you can do that. So what's happening is this. First of all, you need to understand this first. And then what's happening here is this. So there is, you can actually break this apart in the middle, right? You can actually break them apart in the middle. So what's going to happen is this. You toss in a random number, so we call that a noise. And this noise is just a random number, right? It's one numerical number. And it's exactly what the question is written. So I'll show you, it's a good question here. So Jingwei Huang asked this question. Can I reverse the model such that I input a number and then it returns the image? This is a good question. Here, I'll show you exactly what that means. A noise, that's a number. And then you go into a neural network, you expand the dimension like this. And once you expand dimension to a certain point, you will recover the dimension of the original picture. So yeah, if your original picture is 28 by 28, this is 28, and then this is by 28, then 28 squared is going to be what? 784, right? And then this is going to be 784. And then you take the 784, you reduce it. So this is 784, and then you reduce it to here, to one number. And then this one number, you're going to compare the similarity. So in other words, the first part is called a generator, and the second part is called a discriminator, okay? And these ideas come from autoencoder. So you need to understand this first, and then you come to step 2, you do this. And this is called a generalized adversarial network. Right. Your cell phone, okay, everybody's cell phone, right? The Google Pixel, your iPhone, all that stuff that you look at the camera, you don't have to enter the code, you recognize who you are, and you will unlock the phone. It's exactly this model, okay? Exactly this model. This is called a human face detector. The whole concept of human face detector is built upon this idea. So I give you some sort of a noise, and first of all you train this 784 first, and once you're able to train that, then you feed the 784. You basically take it down here, and then you go to this network. You compare similarity. Similarity is a score, right? It's a number, right? It can either be high or low. If it's high, great, then it's your face. If it's low, it's not your face. Okay? Then if you have a John Doe that you have no idea who this person is, right? Let's say you have a different person stand here and give you a different picture. The similarity is going to be low. If it's your own face and you already check it, right? Then it's going to be a high model, a good model, right? So this is going to be high. The similarity is going to be high, okay? And if it's a high similarity, then great, unlock your phone, right? And as a matter of fact, it turned out that this model, it doesn't really need like tens of thousands of pictures to train. This model is highly related to another type of learning strategy called a one-shot learning. A one-shot learning, or maybe you heard of this concept called a few shots learning, right? The one-shot learning or few shots learning is essentially referring to this type of task that it's most likely for entrance, some sort of supermarket entrance or your front door, right? And then or for your some sort of security camera. If it's John Doe, right, some random guy you met on the street, obviously don't unlock the door, right? If it's your own face, you can unlock the door, right? Do you think that iPhone have to take tens of thousands of pictures every time you open your phone, and that's how you learn it? No, right? You look at the phone for like what 2-3 seconds, and then you should you recognize your phone, you recognize your face, right? And that's exactly what it is. It doesn't need a whole lot of pictures. You just need a few images. And as a matter of fact, the original one-shot learning is actually designed on the idea it only takes one image to be able to train this, right? It's super fascinating. So this is probably a little bit beyond the level of this course, but if people are interested in, I have resource to guide you guys through this. But you do have to understand the step one first. You can't just jump directly to step two. That's going to confuse you. But that's a great question. It leads to it's a good intuition to have if this is something you think about and I mean either you read from somewhere or you magically think about it. If you read from somewhere, great, right? Keep reading. But if this is something that you just like looking into the sky and you just magically have an intuition, then dude, you are the material for deep learning. Okay, so take my words for it. Intuitions like this, they don't come by very often. If you have intuition, please chase your dream, right? Please chase down that path. It will do you a lot of good. All right. What other questions do we have? Oh yeah, I have to make sure to send these questions to Sam. These are great questions. Thank you for asking. Make sure that let me know if you are interested in continued conversation. I think a lot of good things can happen from here. Okay, so let me Control Z for all of these because we don't need that. So okay, so from here, I want to show you guys. We did a little bit Q&A, right? People have questions about the script, and we just explained a couple of the pain spots where people find it might be roadblock for you guys to do your own projects. So that's the Q&A part, which is really good. So from here, I want to do a couple of things. So first thing is I want to set you guys up to give you guys the tools to develop installable package on GitHub, so that all these functions you never ever have to recode again, right? For me, I don't code the same model a second time, right? I code one model once and that's it. And I want you guys to think in terms of the same direction. So try not to repeat your code, okay? This kind of stuff, you only repeat it when you're interested in the idea and you need a lot of modification. But if you know what you're doing, do it once and save it, okay? So let's just do that. So that's one thing I want to show you. Another thing I want to show you is what are you going to do with the results now that this is done, right? So first thing first is I want to show you guys the slides of essentially the presentation that I think it could be beneficial for you guys. Obviously, you don't have to follow the templates. Where to go? I think it's this one. So this is a template that I had for the last class, and as you can see, it's super simple, right? Nothing happens. So I'm going to walk you guys through the important part, and now, of course, all the videos are online, and they are the recorded session for the previous presentation. So this weekend, when you go back home and when you do your own research and when you do your own data science project, right, for the next week as well, try to think in terms of the deliverable, right? Think in terms of how will the results look like on the presentation slides? Okay, so that's one thing I want to mention. And the next thing I want to mention is GitHub, right? Because you do need to have a GitHub link for all of your projects together. And the higher version or the higher bar is if you can write a GitHub package. I don't think last session we have the thing as a GitHub package. I think everyone just have a GitHub link and they put their data on it, they put their script on it. But I think this session, since we still have a couple of days of time, I'm going to try to push for that idea. So that in this case, you guys have much higher quality of GitHub to showcase what you've done. All right. So let's try to set this up, and then we'll give you guys a break. So on a high level, every presentation, of course, have a title page, and then in the end have a summary, right? So this is of course very straightforward. I recommend you guys have like some sort of executive diagram. You don't have to call executive diagram, but you need to have some sort of roadmap of what you've done, right? Don't just open a presentation and say, oh yeah, we got 90%, and no one knows what that means, right? You start with data processing, and what project are you doing? Like, what is your topic, right? And then you talk about the model, and then you talk about evaluation, test set, and the performance. So make sure that you have something look like this. It doesn't have to be exactly like this, but something that look like this in the first slide, okay? And this is one of the things that, of course, it will make your a fellow audience a little bit easier to understand. And Sam and I, we will be evaluating your presentation. So this way, it helps us to understand the material a little bit better, right? So that's one thing. Everyone, please start with this slide after the title page, of course. And then the next thing is always have some sort of graph to show people what data you're working with. If it's a picture data, then give a couple of plots of pictures, right? If it's a tabular data, then you can show the histogram or the scatter plot, right? So if there's a linear pattern, you can kind of show us what that is. And then when you explain the data, you can just use a visualization, right? So it makes your life a little bit easier. And then the next thing I always have is to have some sort of slides indicating what model that you're doing. Either you're doing a linear regression model or some sort of neural network model, you need to tell us, right? If you just say model, no one knows what you mean. And then after that, you can essentially give a couple of plots for the prediction if you want to, or depending on what model you're doing, you can have different plots showing that the model output, right? If it's a picture, then you can try to print a picture, right? So that, of course, comes with the model construction and just how you're doing your model. And then after that, you can have a table showing this is your model or this is your test set, or maybe you have different tuning parameters, and then you change something, and then the model is better, right? So then you can write all that here on this slides, and that's it. That's really what we're looking for. It's not meant to be a complicated project. It's meant to allow you guys to take the code from class or whatever from internet to put together a data science project that it's a topic that you like, that you find interesting, and you just walk through the process just once and showcase what you've done. And that's what we're looking for in this project. So today, you guys should know who you're partnered with, or you're doing your individual project. Let us know the preference. I think I've received maybe 1 to 2 requests. I don't think I received all of them. So yeah, please let us know. If you don't do it, otherwise we're going to assume that you're in a team of random assignments. And then after the break, when we come back, I'm going to give you guys a source of the data and how things work on GitHub and what does the final presentation look like. And then that will probably be it for today. All right, so let's take a break. Let's just do 10 minutes, and then after 10 minutes, we'll come back and we'll pick up from here. Like this. Wait, what am I looking at? Oh, okay. So the thing about making a deliverable like this is really regard to, well, A, it makes your life easier, so you don't have to recode anything, and B, hopefully it makes your audience's life easier, whether that audience is your classmates or your instructor or whatever's online is reading your paper or project, right? It doesn't matter who they are, but hopefully it makes their life easier as well. So the idea is this. We've gone through all that work, right? And this is like a whole script of code that you have to write to actually get to the performance in the end. If it's a regression problem, you get a table like that. If it's a classification problem, and you scroll down, 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 all the way, you get a table like that. Now, of course, throughout the middle, you might have to repeat this code a couple of times, right? Recall what we did. We started with logistic model. We did not use a one-hot encode, and turned out the accuracy is pretty bad, right? 10%. With 10 classes, 10% is basically random guessing. So what that means is the model hasn't really learned anything. And then we're like, okay, let's do 10 class, but let's actually use the one-hot encode. And of course, the model started to learn something, but it's not perfect. And then we start making it deeper, either with more epoch or with more neurons in the first layer. Either way, you see a jump in the performance. And the increase to 100 epoch has shown to be much better help in terms of the increase of accuracy. Okay, so we've done all of this stuff, and if you're paying attention, you realize that throughout the middle, what has happened is we run through this code a couple of times where we don't really know, we don't really have a fixed way to avoid have to repeat writing this more than once, right? So what that means is the agenda is very simple when it comes to either in production environment, or if you're handing the code over, submit online, making publishable, it doesn't matter what the end result is. End of the day, you're gonna make this kind of like a pipeline, like modularized, right? So what that means is hopefully these numbers, they should not be in the middle and you have to change it and by rewriting the code every time. Hopefully there's something in the middle, there's something in the beginning that you say arguments, right? So input arguments, and then you just define it, 128, 64, something, 32. And then everything below should automatically run, right? Wouldn't that be better, right? So today we're gonna do that, and we're gonna see how we can do that in a smart way, okay? So here's the caveat. Notice that these lines are hard-coded, right? It's kind of like if I want one more layer, I have to physically take this, copy, and then put it down here, paste. That will give me one more layer, right? And I have to change this number to whatever, like 10, right? I have to physically do that, okay? And you can imagine a process. If in the end, I want a table of 10 experiments, you gotta do that 10 times, right? That's kind of how things work. So how to make that easier? Well, what if I just change things here, or even better, I write a for loop, right? That will make it even better, right? That will make it much faster, so I don't have to do any of this, okay? So we're gonna try to do that a little bit. The trick here is this. So what I'm gonna show you guys, I'm gonna open up a new section. I'll just put it here. It's called, actually, I don't wanna put it there. I'm gonna put it down here. So we're just gonna call it, say in production. Right, so in production, what does it look like? So I want to have some sort of input arguments. And I want to be able to just say, hey, my params is 128, 64, 32, and I'm done, right? And specifically, this is, of course, for the hidden layer. So we're just going to say hidden, right? And then everything else, you can literally just copy paste. So I'm going to just grab that, and then I'm going to come down here, and I'm going to define the code, right? So this way, you can say, well, let me just, get rid of all of that, right? And then here, I'm gonna say a for loop for I in hidden. And this is called an indentation. Basically, you hit that tab key on your keyboard. You have to have this for the for loop to work. If you do something like that, it won't work. Or if you do something like that, I think that probably should be able to work, but it's better that if you just do a tab. So it gives you the correct indentation. Now this is what we want to change, right? So think about it. If I define this for this list here, this array, not array, this bracket looking structure, right? This is called a list. A list is a vector of numbers. And when you write a for loop, for I in hidden, and then you say print I, this is going to give you each item in the list, right? If the list is 28, 64, 32, then you print out 128, 64, 32, right? So that's what we need, okay? So we're gonna write this, but in here, in the model. So this 128, we're gonna change that to I, where the I, it's different number every time the for loop continues, right? So that's something we can change. And in addition, you can probably, I probably give the name, right? You can say name is layer plus string I. And the reason I say that is because if you do layer, it's a string, right? It's not a number. It's not 1, 2, 3, right? It's a string. So if I add a number, let's say 128, this is not going to work. And the reason it's not going to work is because one data type is string, the other data type is a number, it's an integer. So they don't talk to each other, right? You can't put them together. So how do you make this work is you turn this into a string. So this str means string. And you can throw in a number, but it's gonna change the data type to a string, right? This will work, right? Now you can say, this is a layer 128, okay? But of course, this is, I don't really want to be 1 to 8 because that's not gonna make any sense, right? I want to be layer 1, 2, 3, 4, 5, right? So what I'm gonna do is I'm gonna define this hidden here, but here I'm actually not gonna use hidden. I'm gonna use range. The range has an input, which is a number, and that's going to be the length. So I'm going to write length, L-E-N, and then I'm going to throw the hidden in there, okay? H-I-D-D-E-N. So what this means is, and I'll show you guys what this means. So if I do a for loop, I in range 3, if I say that, this I, right, this for loop will print out 0, 1, 2. Because 3, it's the number of integers up to 3. And Python definition is the beginning we include and in the end we exclude, right? So if you're 3, then you stop at 3, which means 3 is not included, okay? So what this means is if you want to have 1 to 3, you better add plus 1. This will give you 1, 2, 3. So that's what's happening here, and I'm going to do that. So the length is just the length of the hidden, right? I can say length of hidden. If there are 3 numbers, then of course it's going to give me length of 3, right? Because there's 3 numbers in it. So then I have all of the functions ready. I say range length hidden, and then here it's I, but it's not I as 1, 2, 3, right? It's I as which number in here, okay? So here I'm not going to just say I, I'm going to say hidden, and then I'm going to say bracket I, because this is going to grab that integer from that hidden list. So I'll show you an example. Let's say I, that's 0, 1, 2, right? I plus 1, that's 1, 2, 3, right? And then if I do hidden bracket I, that's going to be 128, 64, 32. Right, so these numbers are what I need. So hidden I just give you 128, 64, and 32. And then the string I gives you 1, 2, 3. But I want to make sure it's a plus 1. So it gives me 1, 2, 3. That's the number of layer. Okay. So with that being said, I think the rest of the code should be pretty straightforward. So I'm going to run that. Sorry, I have I have a typo. What is maybe it's not called a name. What is it called? Oh, my bad. This should be inside of the dense layer. Aha. Is that a thing? There you go. Okay. So sorry, my bad. This name needs to be inside of this dense layer. So what I was doing is I was writing it here. Okay. This is the model.add. The model.add doesn't have argument called name. Okay. The name argument is in dense layer. So that's the difference. All right. So once I have that, and I can just maybe do a plot or something. But here, let's do a model summary. See if that helps us understand the summary. Oh man, I need to compile it. Yeah, that's an annoying thing. All right, let's compile it. So let's do we'll just compile it here. So compile. And when we do compile, I believe we can just copy the code here. There's really no reason we have to rewrite this. So what I'm going to do is I am going to put it here. All right, and then does that give us a summary? Model.summary. Still? Okay, then let's do the .fit. So fit. And then let's put it here. All right, so this way we are able to have, essentially be able to train the model. But I'm going to do a 10 epoch just to not kill our time, right? Let's just do it real fast. So this way, it's a quick way of basically defining this argument and run through this entire thing. And quickly, you train however many epoch that you need. And then as this is training, I'm going to make this code even more productionized, right? I'm going to take this validation split, and then I'm going to treat that as an argument so that people can define it in the beginning if they want to. So I'm going to put that here. Oops. I'm going to put that here just a sec. And then the validation split, I'm going to override this. And then the epoch, which is 10, I'm going to put it here. And then this, I'm going to replace it with epoch. And then these two lines of code, I'm going to get rid of that. And then I'm going to put up here. And then this for loop, I don't need that because that's just a draft. All right, so pretty much everything in this chunk of code is essentially soft-coded in the beginning as argument, right? And then 86%, so that's kind of what we did before. Now we should probably be able to do this. Okay, so now we have a model. Let's change this because this is flattened 5. I don't like that. So let's change this to name flatten. All right, let's do just one epoch or two epoch, and let's see if this runs. So if that runs, then that's great. All right, so it is running, and hopefully it gives us something what we want. All right, okay. So it's two epochs, so it's not going to be that accurate, but that's okay. We're going to check out the model. All right, so now that's flattened, so the name is changed. And then I believe we have to change this name down here as well, because no one understands what that means. So this name is going to be output, and that should be easier to understand. And then here, I believe we also have a name argument, right? Name. So you can say, I'll say model Sam. Okay, so run that, and then I run that. It will train two epoch according to these parameters. And then after two epoch, I print out this model.summary, and it should give me what I want. So model Sam, these are a couple of layers, okay? And this way, it's essentially streamline the production. And then you can even do more about it. You say, hey, the loss function, let's make that productionized. So we're gonna grab that. And then this thing is gonna be loss, and I'm gonna put the loss here. So I'll say loss equals MSE. And then this doesn't have to be SGD, right? Of course, it can be defined by whatever you want. So optimizer, and you're gonna put it here, optimizer. Somebody have a question? What does the layer flatten do? How does this affect the model? The layer flatten is specifically defined for this data set, right? So that's a good question. If it's a different data set, of course, you don't really have to use flatten. Right now, we haven't learned convolutional neural network. If you use convolutional neural network, this will probably make more sense. But right now, the flatten just take a vector and expand it. So let me draw out for you. So if you have a picture, right? Let's say that's your, oops, let me use different color. Let's say that you have a picture like this. And maybe it's a 2x2 matrix, right? So maybe you have 1, 2, 3, 4. Right? So pictures are essentially pixels. If it's 2x2, it's 4 pixels, right? Flatten means this, flatten, right? Flatten means this. You take this number 1, and then you put it here. That's 1. And then you take number 2, and then you put it here. That's number 2. And then you take number 3, and then you put it here. 3. And then so on and so forth. You get the idea, right? 4, right? So flatten just means this action here. You take each pixel, you take them apart, you put them side by side, and it becomes a big vector. So that's what flatten does. And the reason people do this is because if you have a picture, let's say you have some sort of pattern, right? Then when you flatten it, you can generate these big vector. It doesn't matter if you draw vertically or horizontally, that doesn't matter. As long as it's a big vector, then you can kind of connect it with your neural network model. Okay? Because if you don't have this thing, like let's say this doesn't exist, right? It doesn't exist. Then it doesn't know which one to connect. Like it's gonna get super messy. But if you are able to generate this, then this is clear. This connect to this, this connect to this, this connect to this, then that's clear. If you don't do that, then it's not gonna make it work, okay? So you can kind of take this as a requirement if your dataset is image. If a dataset is a CSV Excel spreadsheet, then it doesn't really matter. You don't have to have that. This is only needed if you are doing image data. Okay, so that's definitely a good question. All right. So somebody else had a question. Is a neural network similar to a data frame? Is neural network similar to a data frame? Not necessarily. It can be, you can write it as a matrix form, which can be stored in a data frame, but it's not a, it's technically speaking not a data frame. Because data frame is referring to the particular things like California housing train, like this kind of stuff. That's a data frame. Neural network is a model. You can force to take the parameters out and you know line them up in a data frame, like an Excel spreadsheet if you want to. But if you're asking for like the intuition or like the interpretation of what the model does, I would not describe it as data frame because data frame means something else. Yeah, so that's a good question. All right. Yeah. All right. Awesome. And right. So yeah. With that being said, now I think we are pretty much ready to take on the next step. So we just quickly summarize everything in this small block of code. Obviously, one last thing I want to show you guys is this 10. This doesn't have to be 10, right? It can be whatever output dimension that you like. So I'm going to call it output dim, means output dimension. And I'm going to put it here, call it 10, right? All right, so with that being said, now we can put things together. So what I'm going to do is I am going to create a function, And I think this is probably the first function class that we're talking about in this course. So just gonna have to pay attention for maybe like 2 minutes and you'll be able to learn everything about it. It's super easy. So definition, a function, right? What do you want to call it? Let's call simple neural network model. All right, we're gonna give a parenthesis, that's the input, and then we're gonna say colon, and then everything below, please make sure you have indentation, okay? So the tab button on your keyboard, tab once, okay? Just like that. If you don't have that, it's not gonna work. And I'll show you why it's not gonna work, right? Say def, right, as define function, right? You say test function, a, b, right? Colon. Obviously, you need to return something, right? So I'm gonna return just a plus b. This is gonna work, right? I can say test function 1, 2. Now, of course, it's 3, right? 1 plus 2 is 3. So hopefully this makes sense. But if you don't have the indentation, right, let's say you do this, it's not gonna work, right? It's gonna give an error, right? It's gonna say expected an indented block, right? It means there has to be an indentation. Indentation means the tab key on your keyboard once, right? Then it will work, right? It's a function and everything falls underneath the function, needs to have like a break, right? So that's the indentation. That's why I do this, right? You know, you see this space here. That's why I do that. And then after that, you'll have your function, right? But of course, you want to return something, right? So here, obviously, you're going to say output, and you better return something. Because if you don't return something, then you train the model, nothing gets saved, right? then that's a problem. Then you're wasting your time. The whole point of this is to save time, right? Not waste time. So what's happening here is all these arguments, of course, you need to put them here in the parentheses, right? Because that's where the argument goes. So you put them here, and again, indentation. So please do that. And then these are arguments, right? So you better have a comma to separate all of these things, right? It's exactly the same as what we did here, right? TensorFlow.chars.layers.dense, right? We have something, comma, something, comma, something, right? So it's the same thing here. If you have your own function, then you better have some sort of arguments, comma, some sort of arguments, comma, and so on and so forth, right? So now once we're done that, then these stuff we can just comment it out, and then that's your function. And of course, you gotta return something. So typically, the object that you return, it's of course completely dependent on you. But I recommend you guys to return at least two things, okay? The first thing is your model, and the second thing is the history, all right? So you should at least return two things. All right, so let's try it. So here, what I recommend is a dictionary. So whenever I do bracket, it's a dictionary, okay? So output use dictionary. This means what? Bracket, right? Specifically, it's a curly bracket. Now, I'm just gonna type out things that I want to return, right? Dictionary means what? Dictionary means there has to be a key, there has to be a value. So it's a one-one map, right? So what that means is I say model, column, and then I give the actual model, okay? Notice that this model, it's not the model that you trained before. This model is locally defined that's coming out of here, right? So this model is, where does it come from? It's coming from here. And where does that come from? That's coming from compile. And where does the compile come from? The compile come from these layers. And where does the layer come from? The layer come from this. That's the flattened layer. And where does the flattened layer come from? The flattened layer come from this. So that's where the logic goes. And that's it. That's the top of the function. And there's nothing in front of it. Okay? So it doesn't matter what you wrote up here. That's completely independent from what's coming out of this model inside of this function. Okay, it's like two different worlds. Okay, so this model really make sure you understand this. It's whatever's defined inside of your function. Okay, so that's the model, and you can kind of call it the first object you want to return, right? And then there's also a second object. So I said history. So you can just put in history. And again, history is defined only locally inside of the function. It's this history here on line 31. It's not anything above, right? That's completely independent, okay? So once you have this, you should be good to go. One more thing I want to maybe remind you guys is these two things. These two things are what we define in the beginning of the script, right? It's not always there, okay? So preferably, you have these two things defined in the beginning of the code. So let's try that, right? What is model.fit? It takes x and y, okay? So let's write that down. This is x equal, right? This is y equal. So when you define it, you better have both of these arguments in the beginning. Otherwise, you can't change it downstream in the code. So once you do that, then this, you can get rid of it, make it x, this, you can make it y. And you might ask, okay, where does this x come from? This x is coming from the input of the argument, which is defined by this x string here. Okay, this way, this function, you can throw in whatever x that you like, and you can throw in whatever y that you like. Okay, and then after that, I think we are pretty much good to go, and then we can just try to run it. So once we run it, right, now everything is saved in this function. And all I need to do is I grab this function from here, all the way to here, and then I come down here, and I grab and put it here, test run. Test run is going to be exactly what I wanted, X string, Y string, one hot, hidden, output layer, validation, loss, optimizer, epoch. Let's do 3 epoch, right? Just make sure that we're talking about the function here. So we'll say test run result. Boom, I run it. Now it's automatically doing exactly what I want. And you can also see the epoch, which is basically the computer is trying to learn the data and it's trying to get better. Now, of course, what is the data here? The data is the input X train here. If you enter this to something else, then that's of course something else. So now this is a train, right? It's done, right? There's a green check mark. This is finished. So once this has finished, I need to get the output out of this object, right? We run this function, we've done all the hard work. Now it's defined and saved in here. So test run result, right? Now we need to get it somewhere, right? We need to get the data out of it. So what we're gonna do is we're gonna notice that this is a dictionary. So what that means is the output of this function is going to be a dictionary, which is exactly what this test run result is. So let's grab that and let's put that here. Check out the result. You put it here. Of course, it's a dictionary. How do I know that? Type. Put that in there. It give you what? DICT. That means dictionary. And then you can check out more things. You can say keys. Every dictionary must have keys. Okay. The keys are exactly what I just typed in. And here, look, I have a typo. So I better come out here and change that. Here is three. So I run that and run that. And then I run that. Okay. Is there a question? All right. So somebody had a question. Do you need it to be x equals to x in the compiling function, or can you just have x? Oh, I see what you're saying. No, you can just have x if you want to. I type x and y because I want to show you guys that's the input of the .fit function. So if you put your cursor up here, it's gonna pop out as a window. It's gonna say x and y. That's the two input. So I just want to demonstrate that this is the input for this one, and this x coming from this, and that's all. Yeah. To make things a little bit complex, but just to explain what this is, you feel free to define whatever you want. Okay. A, right? A, right? This is B. If you do that, that's fine. You can do that. You just need to make sure this is A. This is B. Does that make sense? So the name in the middle, you call it whatever you want. These x on the left-hand side of the equation of the equal sign, that has to be whatever the .fit function accepts. Okay, x and y. Exactly what you call these data in the middle of the function, you call it whatever you want. Okay, so that's too silly. So I'm gonna get back to x and y. That's x. That's y. All right. So we don't have a run that. Oh, by the way, let me just throw that in there. So let's say you can also do a. Oops. You can also do a. Just put it here. So you can say print summary, and you can have a check mark, right? If verbals, you can say print this. Oops. Yeah, and then verbals, people might get confused. What is verbals? Verbals, you're gonna have to define up here. Usually, if verbals equals to true, it will trigger the if statement. So you say if true, then you will print this. If it's false, then it won't print this. Okay. So let's try it. We run that. This you can get rid of that. Now here you just say verbals is true. Oh, come on. Model has not been built. Wait, did I mess something up? Verbals. Let's see. Oh, I get it. It's because I haven't built the model. So this needs to be moved down. That's annoying. Put it here. Right, my bad. Okay, now let's try it. So yeah, so you're gonna have to fit the model first, and it will print out the summary. So that's the annoying part. All right, so 2 epoch, 3 epoch, and then after that, since I did true, then you better print out something, right? So this way, I know what my model is. I can check each layer, make sure it's exactly what I wanted, right? And then you can do an output, right? You make sure the keys are correct, model and history, and then you can say test run result, You can say model, and it will give you the model. And then you can do predict, or you can do evaluate, and then you can throw an X test in there. Is it X test or X test? Is that a thing? X test is not defined. What did I call it? Here, X test one, Y test one hot. Okay, let me throw that in there. So this is evaluate. Yeah. So this way you can evaluate real fast, right? So something like that. Of course, we haven't trained for a whole lot of epoch, right? We only did 3 epoch. So of course, this is not going to be very good, right? So that's kind of the story here. And then this makes your production life a little bit more easier. So you can quickly update and change this, right? This is only doing it in Colab, right? Now I'm going to show you guys how to do it on GitHub. So this is a function here, right? Obviously, don't lose it. So we want to throw up on GitHub, and then we want to make it installable, right? So here's how things work. And if you guys have GitHub, you can follow up. It's actually not a super complicated situation. So I'll walk you guys through it. First of all, you need to have GitHub. You need to have an account. Obviously, register with your personal email, right? Not the Columbia email. And again, I hate to say this. I wish all you guys come to Columbia, and Sam is gonna wish all you guys go to Yale, right? But unfortunately, not everyone of you guys is gonna make to Columbia. So please use your personal email, okay? Otherwise, you're gonna lose this work of yours. So top right corner, there's a plus button. So you press on that, and there's this button called a new repository. So you click on that, and then it will bring you here, okay? So I'm gonna just create a fake one, and then as a demonstration purpose. This template, I don't care about that because we're gonna build this from scratch. So here, I'm gonna write out some random name, just say random deep learning, okay? I'll do a little bit easier, so random model, okay? Please don't do space, like don't do this, or like don't do like something weird, right? Just, even though that's available, my recommendation is this way you save yourself a lot of trouble later on, okay? When you jump into a different system, the dash means something else in different systems. So, this way, just make it one word, no space, no special characters, nothing like that. Just all English letters and just call it like that. Please make your life easier. Don't try to be complicated. And then this is a one sentence description. And you can call it whatever you want. This doesn't really matter. And then make it public so people can use it and people can install it. If you don't do this, then people won't be able to access your code. So that's going to be a problem. I would always add a README file, so I would check that box. This you can just ignore it. You don't have to do too much. You don't have to care about it for now. License. I always go to MIT, so I'm going to select that one. And I usually recommend that one. That just is a little bit easier to manage. And then that's it. So you just create a repository, and that will bring you here, okay? So here, what's here? What we're going to do? We are going to create a package, okay? It's going to be an installable package, such that whenever you finish doing it, you can bring that into Python. Okay, the first thing is add file, and then create file, and then we're going to enter some name here. My go-to strategy is I just call it the name of the field, okay? So let's say we call it, let's say deep learning. How about that? Because the neural network model, right? Deep learning. And then if you do a slash, it will bring you to a different folder. So this is one folder, this is another folder, and you can keep doing it. That's another folder, that's another folder. Okay? So sometimes you see nested folders. Like, why do we have TensorFlow like this? tf.keras.layers.dense. That's because they have something like tf.keras.dense. Right? That's what they have. Okay? So that's what we're gonna do today, is to learn that directory. But we're not gonna go that complicated, right? We're just gonna build once. So deep learning, that's one layer, and then the next layer, the next level is going to be what we put the function in. Okay. First thing, obviously, we're gonna set up a README file. It's going to be a markdown file. Okay, so we're gonna say dot and d, and then you're gonna say something here, README. this is where I save the function, just to make sure that people know what you're doing, right? Readme. And then you can just say commit, right? That's it. So you save it. And that's where it is. Now you're gonna do a couple more things. You're gonna say add file, create new file, and this is gonna be very important. Okay, so please pay attention. You're gonna do underscore once. Sorry, that's not underscore. Underscore once, underscore twice, init underscore once, underscore twice, dot py. Okay, so I'm gonna zoom in. I'm gonna do it again in case people are somewhat getting lost. All right, so underscore, underscore, there are two underscores, okay? init, and then another two underscores, underscore, underscore, dot py, all right? That's the name of the file. And in here, please leave it empty. Don't write anything in here. And then click commit. And then you wanna just check it real fast. So click on this, and there should be nothing in here. It's completely empty. Okay, if there's something there, then something's gonna go wrong. So don't have anything, it's empty script. All right, so we're almost there. Now we're gonna create the actual function. So we're gonna say create new file, and then we're just gonna say modules. Usually I call it modules. If you want to call it models, that's fine too. As long as it's something that makes sense to you and you can memorize. But I'm just gonna call it modules. And I'm gonna say .py, okay? So this is going to be a Python script where we save the function inside, okay? So what we're gonna do is we're gonna come back here and I'm gonna grab all of this, okay? And then I'm gonna put it here. Now notice that a couple of things can happen. Here, it's relying on TensorFlow library, right? So I actually need to import TensorFlow, otherwise it doesn't know what it is. So let's say import TensorFlow as TF. And then TF, so all that should be able to work. I believe that's it. And it's the same thing, right? If you have a new library, linear regression or whatever scikit-learn library you want to use, obviously you have to import here again, right? Otherwise, the script doesn't know what to look for. And then these are variables that my recommendation is you switch to none. None means an empty object. So this way you can input whatever you want. These numbers doesn't really matter. If you want to default these numbers as well as strings, that's no problem at all. Okay, so that's it. All you gotta do is copy the code here, and then this is going to be these are none, right? And then yeah, that's it. You can click preview. Just make sure that you're reading everything. Everything sounds right to you, and then you just say commit. And that will put this module here. And you click on it, double check everything, right? Looks good. So now let's go back and we're gonna do one last thing. This last thing is called the setup, okay? Add file, create new file, and with no setup, setup .py. The setup function, there's a template. I'm not gonna bore you guys, I'm just gonna put a template in, and I'll show you guys what to do. So this is the template, okay? From setup tools, import setup. And then you have a setup function, and inside of this function, you're gonna enter all these things. But I need to change it because this is a random model, right? So this name needs to be random model. Author, I don't care much. Email, as long as it's valid, I don't care much. License, don't care much. Description, I don't care much. But this package, you have to worry about because this package must be the name that you just defined in the folder. I'll show you. So you go to random model, you right click, and you open up a new tab, and you go to your main directory. This is where your function lives, right? Your init and your modules, they live here. Okay, so where is here? Here is called deep learning. Okay, so I gotta use this folder, and it's case sensitive, so I better have the exact same letters and the all small cap, right? So I copy that, and I come back here, I paste it. So now this deep learning all small cap. Then we're good to go, right? So you go down here, you say commit, and now you're ready. Okay, so now this is ready, and then I can take this URL and I'm going to physically install it in the Colab. So I'm going to grab this, and then I'm going to come back here, and then I'm going to say exclamation mark pip install git plus this dot git. And I'll just give a comment, say install my own library. Enter. So now it's gonna obviously take a second, and it's gonna go to that URL and download everything that it can and turn it into a library. Now my life is easier, right? Instead of doing all of this, right? Or instead of going up here and define this line by line, now I can go down here and I say, look, I'm gonna do from random model. Where'd it go? Is that another thing? Random model modules. Random model is not defined. Maybe I messed something up. Here, let's see. Random model. Or maybe it's called this one. I always mess them up. Maybe I should double check that. Deep learning, is that a thing? Modules? Deep learning is not defined. I might have messed something up. Random models. Let's see. Random model. Is it model or models? Random model. Random model. And where's the typo? There has to be a typo somewhere here. Random model and then deep learning. Deep learning is here, and then let's see modules. And then let me check this again. Let's see. All right, let's come back to this. Collected package random model, building on this create a wheel. Yeah, it should be called import random. There we go. Okay. Oh, thank God. Import random model, and then no modules name. Okay, so maybe you should do deep learning. Is that thing? Or from this import, and you say something, right? Or I say import this. Oh, actually, hold on. Sorry, it's the modules. I keep messing up. No module name. So maybe it's import deep learning modules. No module name. So import, and then how about this one? Oh, there you go. Okay, I keep messing up for some reason. So yeah, so the function is already installed. So all I did is you just start from deep learning modules. So that's where I messed up. You actually don't need to recall the function name. You just need to start from here, this level here. So deep learning modules, and then you start from the second level. So that's where I messed up. And then the function should be here, right? So what is function? Simple neural network model, right? So we're gonna call that. So here we're gonna say, once this is imported, you can come down here, you can say simple neural network model. See, now it's here. I enter this function, right? Now you can just call this function, and then you can basically define whatever you want, right? You can say parenthesis, and then since we already defined everything here, I'm just gonna go here and grab all this input, and then I'm just gonna put it here. And it better work, right? Because that's how I define it. Of course, I need to tell the computer this is X train, and this is Y train, one hot. And then let's make it a little bit complicated. Let's say this is 256, 128, 64, 32, and then this is maybe 16. Output is 10, right? Because it's 10 classes for this particular data. This, let's change to 1, 10%. And I think this is pretty good. So I'm going to do 5 epoch, or let's do 10 epoch, just to be consistent. And let's make sure we save everything in object, right? So we're going to call it test run result 1, and I run it, right? Then something will happen. So now this way it will run it. Now this is running, of course, on this Colab, but the function is coming from whatever we just installed from this library here that we just created. Okay, it's here. So I'm gonna copy this and put it in a chat. If you guys want, you guys can of course go in there and yes, you can take a copy of setup.py. Setup.py is exactly like this. You're gonna have to change the name to whatever you define, right? Your own name, right? And then whatever your own email is, right? License, you can just leave like that. Description, just one sentence of description. This is my AI model, right? Make it simple. The only thing you have to be aware is this package. This package has to be a bracket, right? And then whatever you do has to be inside of a quotation mark because it's looking for the path, okay? Where is the path? The path is here. That's where I messed up earlier. Deep learning modules, that's it, right? That's where the function lives, okay? So yeah, so check it out and make sure everyone should have your own GitHub and every team should have your own GitHub. And whatever function that you coded, please throw it up here, okay? So that's what I want to say. And then we're gonna come back to this. I'm gonna check everyone's code, just make sure that everyone has an installable package. And then we'll talk about how to make this a little bit prettier. But for now, just you don't have to worry about this right now. All you gotta do is have your own account, and you can have some sort of GitHub repository. You don't have to make a package yet, because I want you to have the function designed first, and you have the results. You're happy with the results. When you deploy it, that's when you come back and write this function. All right, and then after that, I think we are pretty much good to go. You can come back here and check the final results. It's exactly what we're supposed to do, right? 10 epoch. Now, obviously, you know, we're not expecting the performance to be that high, right? Because you only did 10 epoch, and this is a little bit complicated model. So of course, 10 epoch definitely has not converged the algorithm yet, right? So you're gonna have to train a little bit more. And that's the output, so that's there. And then you can check out the output, right? The output of this entire object is going to be a dictionary. So once again, type, it's right in there, dictionary, right? And then you can check out the keys. It give you model and history. And then you can do whatever you want. You can say test run result 1 model. You can do a dot evaluate. And then of course, whatever it is that we have here, right? Let's throw that in there. And then let's come back up here. And then let's throw that in there. Boom. Done, right? And everything, all the junk down here, I can just get rid of that. Right? Now this is clean, right? In production, what's a clean code in production? I install my function, right? I don't need this, right? Because that's just we just want to print out the function that exists, right? Import the library, exactly the same way as what we did before, right? Input something as something, right? But I didn't have S, right? So you know whatever it is, we can just load it up in the environment, and then I have this function, right? And then you just run it. Once you have a function, you define your input, you run it, you will have results, and then you evaluate it, done, right? So it should be very, very clean, right? Very, very clean. And then you're like, okay, let's do some, you know, tuning, right? Now you can get back here and then redo these experiments. Now it will make your life much easier, okay? How do I know that? Now, this is gonna be when magic happens. You can take this, and then you can go down here, and you say, for some tuning level in range, we're just gonna say a bracket, and then you're gonna throw the function down here, okay? Now you're gonna make your life much easier by doing this. This is gonna be this letter here. What do we say here? We say 128 is an assumption, right? You do not have to have 128. You can have whatever you want. And we've shown here, if you do 1024, you will have a higher performance than 85%. That's what we've shown here, right? So why don't you try a couple of more things? But then you don't want to repeat the code every time. So why don't we use the library? So you have your library here, and then you throw that in a for loop, right? This now you can play around. 128, 236, 512, 1024. And then you trigger it, it will run everything, right? Now all you gotta do is save the results somewhere. So some results portfolio. This is gonna be empty place folder. And then whatever this is, let's just append it, right? Some results portfolio dot append. You throw that in there. Boom, done. And then I'm gonna make your life even more easier. We're gonna import. I'm gonna say from tqdm import tqdm. This is the library for progress bar. For progress, it doesn't really matter. So maybe you don't need this because we're gonna have this kind of output. So you don't need progress bar because it's gonna conflict with this progress bar. So let's get rid of the progress bar and then let's just run like this. Let's make this false because I don't want any output. I just want a progress bar. I don't want this. So there, that should be able to run. I'll run it and then we're gonna go take a break. And then when we come back, we're gonna take a look what this thing looks like. And this way, it will give you guys much more toolkits to essentially wrap up a project. So here's the game plan. We're gonna take a break. We're gonna come back. We're gonna regroup, and then we're gonna do a little bit Q&A. And I think we can just stop early because we're ahead of the schedule, and I'm pretty happy with the progress. So we don't have to stay all the way to 8 p.m. It's a Friday. Everyone take a break, right? And we can just do a quick Q&A, checking, and then we'll just drop off. So take a break. I'll see you guys in 10 minutes. All right, so right now I'm looking at my GitHub, and this is a random model library that we just created in the previous hour. So how do you edit is this. Whenever you go to a certain file, let's say setup, you click in there, and then it will bring you here, right? And then all you gotta do is click on this button that looks like a pen or pencil. You click on it, it'll bring you here. Now, of course, you can type in whatever you want, and you can edit it, right? And then once you're done, let's say I make some edit, just some space, that's an edit, right? And then you can click commit, and that will save the file, okay? So that's how you add a file here in the setup. And then what if you're doing something else, right? Let's say you go to random model, and then deep learning, and then modules. You don't really have to have one function. You can do whatever you want, right? So I'll show you guys what I've done. This is a library for myself, and I use this for my own company. There are a couple of folders, right? It's an AI solution, there's computer vision solution, financial, machine learning. Each folder is by itself a portfolio of functions in there, right? Whatever it is that I use, that I find useful, I just throw up there. So I can load on myself and I run myself. And all I gotta do to make sure that this directory is correct is I go to setup, and then I go to my package, and I make sure that each of the name of the folder is listed here. And if it's listed here, then the Python interpreter will go into a directory and look for these names and create functions for them. So AI solution, that's here. CV solution, that's here. Thing solution, ML solution, they're all here, right? And they are each individual folder in the main directory. Of course, case sensitive, right? Now you can click on each one of them. And then there's always an init, and there's always a module.py. Now, of course, you don't have to call it module.py. You can call it models.py or whatever you want. But you do need these two files. Init, it's always named 2 underscore before init and 2 underscore after init. And then the modules.py, you just throw in whatever function that you want in there, right? Here, I have a class object. So what that means is every of these functions is saved under this class object. And that's kind of like a big library that save all the functions together. So if you have a class object, you're just gonna have to do one more dot. Like let's say I have yins.dl, so it's just gonna be yins.dl dot, and then I can call any of these libraries in this directory. Okay. So that's kind of how things work. And then whenever you want to add a function or add a Python script, you just come to top right corner and click on this pencil logo. And then you click in there and you bring you here. And then you can type whatever you want, right? You can say this is 16, right? 16. And then you come down here, you say commit. Commit means save, okay? Commit. Now you're here, 16 is here. All right, so now you go back and then you can load up, right? So what we just did was we went in here and we installed it, right? So we're gonna want to save that in our directory or in our README file. Otherwise, people are gonna get confused how to use it, right? So whatever it is that you run here, let's say it worked, right? You have your analysis, you have your results, you're happy with the results, you deploy it, you write the installable package, everything's done, right? Now you come back, you say, hey, I am going to copy this, and then I'm going to put it here in the README file. So this pencil button here, that means edit. So you click on that, and then you bring it here. And then you can have a section that's called manual, right? Or you can call it user manual, something like that, kind of like an instruction, right? How to use the package. So you say, please use the following code to install. Let me zoom in just so everyone can see this. Right. So now you say, I'm pressing the apostrophe, the button next to the keyboard, the key number 1. That's the button I'm pressing. Press 3 of them. Come down here, 3 of them, right? And then you just paste everything here. This is how you install the library. So you say, install this library. You can preview it. Of course, it will look like this. And the reason I do the ... is because here it gives you kind of like a nice way to copy it. So if you put your cursor here, see this copy button, you copy it, it'll be a quick copy button for the user to copy paste, for other people to copy paste this line of code. So they don't have to type in the entire thing, right? So I come here, I do this, and I come here to my Colab, and I do code, boom, it's here. So this just makes your life easier, right? And then I can go back to edit, and I can say maybe run a small function, right? But you gotta import it, right? Say import ... import, and finish the dots, and then you can run the function. So you can say run this function, run the function by using the key, by using the code below, and then put it here, and then you get rid of that one just to make things a little bit cleaner, right? And then down here you can say the keys. So the keys is obviously output is stored in a dictionary. You print out keys. Display keys of the dictionary, right? So this way you tell people, okay, here's a user manual, right? You install it, you import it, you run a function, boom, you have your keys. Those are your results, okay? So that's kind of like a quick way of showing people what are you supposed to do, right? What they're supposed to do when they see the library, right? They gotta do something, right? They need to run some function. And then when you run some function, some results come out, right? So all of this is complete up to you to design whatever function that you like, okay? I'm just giving an example of this entire pipeline so that you know where things go and you can kind of like plug them together in a way that it's helpful for yourself. So once you do that and you're happy with the README file, I would probably write a little bit more. I would probably get a picture, right? Usually picture is a little bit more, it will just attract people a little bit more and increase some of the online traffic. So I'll say neural network model. I usually do GIF or GIF, right? It's an animation. The reason I like animation is because, well, it's animation, right? So whatever, let's say this one. So that's a nice animation. So I right click, I go to copy image address. So I click on that, Now I have the path of this GIF file, right? Now I can come here and I can, let me close that one, and let me come here. Let me go to the beginning, right? I'll say exclamation mark bracket, I'll say main, and then close bracket, and then you put the URL in the parentheses. I believe this should be able to work. Yeah, there you go. So that's how it works. So yeah, so you have a GIF here, and you can say, this is my neural network model, or whatever you want to put down here. That's fine. If you want to do a, if you want to have your teammates name here, that's also fine too. So you can say teammates. Whenever I do a hashtag, that means I'm going down a different level. So that's level 1, that's level 2, that's level 2, something like that, right? And then you can say teammates are John, Tony, blah, blah, blah. Something like that, right? And then you can say contact something at gmail.com, right? So all of these things you can take care of. You have a picture and you have your Gmail, and then you have your user manual, right? Now this is a well-rounded package, right? People can actually see it, people can actually use it. So commit, and now you have this, right? So that's kind of what I recommend you guys to use. Of course, this is going to be much more easier. You can write whatever you want and publish whatever you want. This is going to be a little bit difficult than that Pi thing. I think earlier people was asking something called maybe PYPL or something. Sorry, not that one. Like pip install IPPI. This one, like this Pi order thing. So this is gonna be slightly different than this one. This one you're just gonna have to. I think they probably charge you money or something. That's really the difference. So if you want this one, you're gonna have to register and then go in there and then upload a package in there. You're probably gonna pay small money, and then they can probably make this installable using a pip install directly in the directory of the organization, so that you can just have your name here, and then they'll install it for you. You just need to have an account, and I don't know how much it is. That depends on how much people download your package, right? But this way on GitHub, that's for free, right? That's for free. Of course, people might also ask, well, I kind of want to charge money, and I'm, having my own startup, and you have your own funding, or you have your own package. That's of course different story, right? Then you need to make it private. You can start charging money, and so on and so forth. In terms of this course, the purpose is to demonstrate the easier pipeline. So a public library is perfectly fine, and all of these functions are all available online. So you don't really have to make people to pay or something like that. So once you have this, I think it's perfectly fine. Right. So that's what I want to say about this, and that's what I want to say about this notebook. Now you have everything ready, right? If you're producing, or if you're trying to predict a continuous variable, right, regression, right? If you want to do a logistic, or if you want to do different classes or different categories, that's classification, right? And once you're done, you throw everything in production, you write your function, or you develop your code here in the code lab. And once you do it, then you gotta save it, right? And then you can do further tuning. So how do you do that? Well, you go to GitHub. You go to GitHub, you write it up, you do the setup file, you have a library. And once you have a library, then you come back to the Colab, and then you have this in production. And then people will know, okay, this is how you install, this is how you import a library, this is blah, 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 right? And then you can do further tuning if you want. So now, during the break, I run this code. It takes a little bit while, because I'm running through each one of these numbers. So let's try it, right? I know that all of the results are saying here, right? Some results portfolio. So let's check it out. I'm going to put it here. So this obviously is going to be a bunch of stuff is in here, right? So let's check out the length. It's going to be 4. So 1, 2, 3, 4. Right? I tried 4 numbers, right? So obviously there are 4 models. So 4 models are all saved in here, and we're good to go, right? Now we're going to check out them one by one. So bracket 0, that's the first one. It's going to give me two things, right? The reason it's giving me two things is because in the library, I have deep learning folder modules, and I scroll down, I have two output, right? That's why I have two things for each model. So I come back here, history, model. These two things should correspond to these two things here. They have to, right? That's the output of the model, and you run the model from the library. It has to. If they don't match, something's wrong. Then you better come here and check the code, right? Or you go to your Python and you refresh the memory, right? You can come back up, you say restart, or you can say disconnect, right? Because something's wrong, like you don't have the correct memory, right? Then you better restart. So all those things are for you to check in case things go wrong. But once you know that this is correct and there are two things which is exactly what you expected, then you can do what you do, right? You can say, dot evaluate. Let's put it here, dot evaluate. And then you run it, obviously it will give you, sorry, I need to call model, my bad. Bracket, model. So it'll give you a score, right? And then you can just compare them, right? You can say that's a 0. Okay, let's do it here. And then that's gonna give us 1. That's the next model, right? Now you have a comparison. And then you do again, right? You say, okay, that's 2. Is it higher? Is it lower? I don't know, right? I need to look at the results. So now you have a comparison. Does this make sense? So as the number increases, your accuracy is increasing as well. Now you have a story to tell, right? So let's put them together. This is obviously a draft, so I'm going to move these 3 code blocks down here. And I'm going to say, let's take a look at the output. Okay, so obviously this is 1 by 1, right? Now I'm going to run them together. So this, I am going to grab the first number. What does it give me? 0.05. So that's this number here. Okay, let's say I'm going to grab this number. Actually, you know what? Let's do this. Let's grab that, and then let's say for I in range 4. All right, let's put everything in the bracket. Now I can change this to I. This will give me the same evaluate from each model, and it's going to print out the results over this test set and the label. Now I have all these numbers. I can just collect them, right? So let me try to collect them. I need to define this as something. So this is the final results together equal to this. All right, so now this I can do whatever I want, right? I can turn it into a table, I can turn it into a graph, I can turn it into whatever, right? So they're there. I run this, it should give me this table, right? And then I can make my life a little bit more easier by saying pandas. Do I have pandas? Yeah, I have pandas. All right, so I can throw that in the pandas. PD, let's check it. PD data frame. There, that's my data. And then I can say final result. final result. Define the final result. And then this is going to be a table, right? And then I also want to specify the columns. So I'll do this one by one. So let me run that first, and then specify columns. So columns. Sorry, plural form. So columns. This is going to give me what is that? Let's see. Oh, sorry, 0 and 1. My bad. So this is going to be a bracket. And then we said that the 0 is what? Loss, and the accuracy is the second one, right? So loss and accuracy. So that's my column names. So I need to redefine as loss, accuracy. All right. Now I have a final result. Right. So now that's clear. And then now I have a story to tell, right? You say, okay, as your number of basically the width of the model increase, your performance is going to increase and then decrease. Okay, so it's going to increase to 80% and then decrease. So what that means is there's a sweet spot in between, right? This is what we've always been saying, right? It's not always the case that the deeper the better, or the bigger the better, right? There's a sweet spot in between. The reason is because somewhere down the road, the number of epoch that we train is not going to be sufficient. Because you have a more difficult model, then you better go 20 epoch, 30 epoch, 40 epoch, right? It's not enough. So if I fix 10 epoch here, which I did, I fixed everything to be 10 epoch because I want to have a fair comparison. Then, unfortunately, this model down here is not going to work, right? So let me change the index as well. Index is going to be 0 to 4, right? So let me change the index to these numbers here. So I'm going to grab these numbers, and then I'm going to put it here. All right, let me turn them into strings so we don't mess things up. And then I'll make them a little bit more meaningful. I'll say with, actually, let's just say this. There's no need to complicate things. All right, final results, there. So now this is a table that makes sense. I can put this table on my slides, right? Now you can take this, right? Let's say, let's save it somewhere, right? Let's say to CSV. Let's give the name, sum result dot CSV. It will physically save as a CSV here, okay? And then you can download it. I'm going to download right now. And it's a small table, so hopefully it should take a second. And then I'm going to open it in the Excel spreadsheet here. That's my performance. Let me make sure I'm sharing my screen. So you guys can see my Excel spreadsheet, right? Okay, awesome, thank you. All right, so now you can do whatever you want, right? You can make this prettier, you can give it some colors, right? I don't know what you want to do. Let's say put a couple of lines. Yeah, I'll just do something random. I'll leave it to you guys. But let's say I add some lines, and then maybe add some lines here. Let's put on top. All right, so now I can copy this, and then I can go to my slides. Where's my slides? Presentation. Okay, and now I can come down here, right? I can open up a new table. I'll put it here. Wait, where'd it go? Yeah. And boom, that's my results, right? So then I have a story to tell, right? I've done all my work. This is an experiment, and I've changed a couple of parameters, and I have a different accuracy, right? And this is just one neuron. We haven't really talked about other things, right? So my recommendation for you guys is pick a data set that you're interested in, and then try a different variety of the neurons, the layers, and so on and so forth, right? And the reason is this is complete up to you, right? It's complete based on your own experience. Because if you don't like this, then you can feel free to change to whatever you want, right? As a matter of fact, you can change 2 of these numbers or 3 of these numbers altogether. Okay, no one says you have to do things this way, right? You can feel free to do something like this. You say, hey, look, you know, I'm not sure if even this is correct, right? Let's just get it back, and then let's put this tuning level here. Okay, and then in here you need to make sure it's a nested list. So a nested list means what? It means this. Nested, right? It means it's a list inside of a list. So you give a couple of things. Let's say 3 lists inside of this big list. And each list, you're gonna individually take that out and throw that into the hidden layer. So here, you define whatever you want, right? Let's say 128, 64, 32. That's my baseline model. And then when I go to the second tuning parameter, I'm only tweaking 1 numbers. So I say 1024, and then everything else stays the same, 64, 32. And then you come down here, and once again, you tweak 1 model. You tweak 1 numbers. Let's say you go to let's say I tweak 64, the second number, okay? So you have like a two-way comparison. So 128, not 64, I'm gonna change 128 and then 32. So think about what will happen when I run this code. If I run this code, the for loop will give me three steps. The first step is gonna take this list and send it here. That's the first experiment. The second experiment is gonna take this and send it here. And the third experiment is gonna take this and send it here. And whatever the result is, we're gonna compare three of the evaluation on each of these model, and you have a two-way comparison. If you compare the first two, the tweak of the model is on the first number. Or if you compare this and this, the first one and the second one, the tweak is on the second number, right? And then I'm not sure if this will make some sense, but you can still compare them and see which one is higher. Because this number is higher than this number, but then this number is higher than this number, so I'm not sure. All right, so I guess I'll run it, but then after this, I think we're pretty much gonna wrap up for today, and I'm gonna let you guys go first. Go a little bit earlier today. So as I'm running this, we're gonna open the room for questions. Any questions? Good? Everything's clear? All right, awesome. So as I'm running, let me send you guys the survey before I forget. Yeah, someone's asking me about these two questions. Yeah, just so maybe it's a little bit unclear as of this point because not all of you guys are applying for college. I realized that just now. So for those of you who are applying for college, okay, and hopefully one of the target is a good recommendation letter, and I'm here to help you guys out. So use these two spots as kind of like a progress tracking opportunity to show me or to tell me each day as you're progressing in this course, what have you learned so far? And it's an opportunity for you to share with me the progress you've made in each of the session. That's why I try to do this every day, or at least if I remember, I try to do this every day, which is to give you guys that opportunity to write this report for yourself as well as for me, so that when I write the recommendation letter, I can take this into reflection. It's not just a regular survey that I kind of see if people like the class or not. It's an actual, I actually take the information from here to write the recommendation letter. So a good recommendation letter, maybe I need to explain this a little bit more. So what's a good recommendation letter, right? A good recommendation letter, especially a class size like this, or even more students, some instructors, they will just copy paste from template and then change the name in the beginning and the end, right? I don't want to do that to you guys. I want to write an actual letter to tell people that I know you and I know what you've done in this class. So this report gives me that opportunity to not just write something random from my own heart or from my own mind, but also have concrete evidence from your perspective, what you like about this class and what you learned about this class. More, I don't really care about if you like or don't like. I care more about what you've learned. That's really going to help me to write the recommendation letter. A good recommendation letter, it's not I confirm the student, he gets 1600 on SAT. That's not a good recommendation letter, okay? A good recommendation letter is if you know the student. Even if you know the student, but the student doesn't get a high grade, or if you know the student is not an A+ student, that's fine. But the point is you know the student and you've talked to the person before, and the student is at the position that he or she is not aiming for grades, but also aiming to build that community, to talk to people. And this is an opportunity for me to tell people that you are able to do that. Does that kind of make sense? So I understand that, of course, you guys are pre-college level, right? I'm not expecting everyone to know the ins and outs of how to write a recommendation letter, right? So maybe I didn't explain that in the beginning. So which is why I want to take this opportunity to further explain this. Recommendation letter is a crucial part of your college application, and it's going to be one of those things that it could set you aside even if you have a lower grades. And I've seen plenty of people go much further using recommendation letter than their grades. Okay, so that's one thing I want to say. And here's an opportunity for you to do it, right? Tell me what you like, tell me what you don't like, so that I know what you have progressed, right? Don't write from your heart. Don't just say what you like, right? Tell me from your heart, like what you truly feel about this class. Like I've had students tell me, I have students saying, I don't like the first day, I don't understand it. I don't like the second day, I don't understand it. And then starting from the fourth day, they're like, wait a sec, I think I have this realization. And then it turned out that's actually a new idea that no one has done it before. And he's on his way to become a computer science major from whatever university that he dreamed of. People like to see that kind of discovery. Like people like to see that you're ground zero and you build yourself from ground up. Like people like to see that, which is why I send this survey every day so that I can kind of somehow learn about that part about you guys, so that when I write a letter, I can incorporate those knowledge in my letter, right? So that I'm not like copy and paste from some template and just change the name in the beginning, right? Does that kind of make sense? So that's what I wanna, that's the goal for the survey, okay? So just be aware of this, and please take advantage of this, right? I'm still gonna try my best to watch all the video recordings, even if you don't write this. But that's gonna make my life a little bit easier because that's from my perspective, I want to be from your perspective. So this is an opportunity to do that. And if you haven't filled out a survey, it's okay, right? We have the next 5 days for you to keep writing this. So really, just take the opportunity and tell me about who you are and what level of the machine learning you are. That's essentially what these surveys are for. Does that kind of make sense? Any questions? All right, awesome. Okay, so I think we are pretty good for today. It's a Friday, right? So why don't we just say let everybody off early, and I'll stay here for questions, of course. But if you don't have any questions, then please have a nice weekend. Enjoy some sun if you're in a sunny area, please let us know your preference if you haven't already. So Sam and I could work that out. From this weekend, I think you guys can think about your project. And I'm going to give you guys a list of websites you can check out. Most likely it's going to be Kaggle. People have heard of Kaggle. Most likely it's going to be Kaggle because they allow you to download data set directly. It's a CSV file, super easy. Just load up on your Colab and you can start running your model. So I'll write it up and I'll send it to you guys on Slack. And with that being said, I think we're all done for today. Have a nice weekend, and I'll stay here for questions. Yeah, take care.
Thank you. Bye.
Yeah.
Could you go over the regression stuff?
Yeah, which part?
The specifically from July 20th, the area on two-class classification, the problem, because I was reading through it and I realized it didn't quite click for me. So if you could go through that again, I'd really appreciate it.
Sure. Let me share my screen so really make sure that I am talking about what you're asking. All right. Okay, so this is July 20th. Which section are you referring to?
Just a little bit below. It's the two-class classification section.
Two-class classification.
Just above that.
Oh,
Yes, I think the set of it's the title.
the title? Oh,
Up a little bit. A bit more.
Here?
Yeah, right there. Yeah.
Oh, okay. So yeah, of course. So let's see. Two-class classroom problem. The output are 0 and 1 because it's two class. It's binary. And then the logistic regression will label the observation as either of two classes, right? Class 1 and then class 0. This is 0.5. It's kind of like assuming that if you are converting something, like converting your classes from a regression, like kind of like a continuous variable. And then they're assuming that the 0.5 is a cutoff. So in other words, you can kind of think of it as, something like a probability, right? 0 to 1, and they're continuous. 0.2, 0.3, 0.4, 0.7, 0.8, and then they're using 0.5 as a cutoff. So this way will give you basically two baskets of data, right? Those are class 1 and those that are class 0.
So
yeah.
if it's lower than the 0.5 else label, it'll go into class 1, and if it's greater, then it'll go into class 0.
Typically greater is class 1.
Got it. Okay.
And 0 is less than 0.5.
Okay, that makes sense.
Yeah. It might be better to draw a graph. So let's see. Let's say you have a graph, right? Maybe this is 0, maybe this is 1, and you have a bunch of dots here. And then you're like, okay, let me use 0.5, right? This is my cutoff. Then this, I'm gonna call it 1. This, I'm gonna call it 0.
So it simplifies the data into two categories.
Yeah, ones and zeros. Yeah.
Got it. Okay.
Yeah. And then continuing from here, you are given a group of images and their correct class labels. So this is the training data. This group forms the training data. Let xi be the ith image of the training set, and yi be the class label of ith image. And each image is a p by p matrix. So which means xi is flattened vector with p squared entries. So this paragraph means this. Let me draw it for you. Let's say you have a picture, and then it's a p by p, right? So this is a p, this is a p. So a picture is a bunch of pixels, right? So what that means is, p rows of pixels and p columns of pixels. That's why the total is a p squared.
Right, it's the total area.
Yeah, and then flatten means that you take this and then you turn it into like a big vector. So that's the first pixel, that's the second pixel, da 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 da, and all the way down here, that's p squared. Because if you take them apart, this goes here, and then this second one goes here, and so on and so forth. This last one goes here. Then you're gonna have p squared, because total is p squared, little boxes here. Does that make sense?
Yes. So this is only for images.
Correct. Yes, it's assuming it's image data.
Got it. So classification is only for images, and
No, you can do classification for other data sets. Doesn't have to be image. It just in this example they use image.
oh, okay.
Yeah.
Are there any like that are isolated to only images? Because I remember you saying something similar earlier.
Isolated to image. What do you mean by that?
Like only image data can be part of it. I forget, but
It's a convolutional neural networks. Convolutional neural. So if you want to do convolutional neural network, it better be image data. Otherwise, it won't make any sense.
right. So convolution only applies to image data.
Image data, yes, yeah. Otherwise, it's not gonna make any. You're gonna be able to get the code to work, but it's not gonna make any sense.
Mm-hmm.
Yeah.
And this applies to any data. Classification applies to any data.
Classification applies to any data that's predicting categories.
Got it.
Yeah. Yeah, so the separation from classification and regression is dependent on what you want to predict. So it's the y that is the definition, not the x. X can be whatever you want.
Right. Yeah.
Yeah.
X is the input variable, Y is the output.
Correct. Yes.
And then could you explain the probability metric?
the probability metric, like what do you mean? Let's see, like the ones down here, or
The one up there, I kind of like reached, I got stuck over there.
yeah, this is probably, I should probably take this off because this is the likelihood function is really kind of like at this point it's kind of like an advanced topic for high school students. So yeah, it's going to be very difficult to explain this to you right now. But what you can think about it is kind of like one way to it's fall under this field called statistical inference, and it's one way to try to identify your parameters of some sort of objective function. It has something to do. It's related a little bit to that giant formula that we derived earlier in the class session, where we have the two equation, two unknown. It's a little bit related to that, where if you want to solve this L function, right, this objective function, you need to take the gradient, sorry, not gradient, you need to take the partial derivatives. So it's a little bit related to that. So the likelihood function is essentially one way to kind of express your objective function, like what you want to do with this objective function. You use the likelihood function. It's kind of like a setup, if you will. It's like a setup to solve for the best parameters.
Got it. Will we be using it? Like, how is it used in when you're normally in data science? How would you use this one?
In data science, this is all coded in the package, so no
Oh,
one really do this from scratch nowadays.
but it's good to know.
Yeah, you don't have to. No one do from scratch. This is all coded in the back end of the library. But remember that two equation, two unknown that we talked about earlier. So you have maybe some sort of loss function, right? Y and y hat, and then you set it up, and then you take the derivative, right? Partial, something like that, right? Beta, and then you set to 0. Remember this, and then do the same thing for this is beta 0, maybe this is beta 1, and then loss function, and then you do this. You set to 0, right? Remember the setup, two equation, two unknown. This is essentially a little bit related to this. Not quite, but it's essentially this is a different setup than two equation, two unknown. You're still gonna have to solve for the best parameters for this likelihood function, but the philosophy is exactly the same. It's just a different setup. So the goal for us to do this, especially for statisticians to do this, is to learn about this beta. And if you know exactly what the beta is, then you have everything that you need to know about this model.
Right.
Yeah.
Then for the two equations, two unknown, is it just what was what you just wrote down here?
Two equation, two unknown. I'm not sure if it's written in this notebook because this is from inference point of view. It's trying to explain. This is actually called the cross entropy function, which we're going to explain on Monday. So the idea for us to do the likelihood to do all of this is to land on this stuff here. So why do people do cross entropy? It's because it's log likelihood function. Why log likelihood function? Is because of likelihood function. Why likelihood function is because of statistical inference. And statistical inference is by itself a whole field. It's basically saying, hey, there's a function here, I have no idea what that is, but the parameter is something I'm interested in solving. Well, how do I do that? You set up the likelihood function, and you take the derivative, you set to 0, and you solve it. And after you work out the math, it will give you the best situation for the beta. And if you know what that beta is, you will know essentially everything about this model.
Right. So that's what the beta and likelihood functions were for, correct?
Yeah, correct. Yes. So typically when people go to school, they do math first, and then they take statistics and probability theory, and then they take statistical inference. So right off the bat, you already like 3 semesters down the road, and then you learn this function. And then once you learn this function, there's going to be another class called machine learning. Machine learning is going to directly jump over and tell you this function directly. So people tend not to fill in the gap. So what's happening here is to fill in the gap. But it could come off as a little bit too technical because this whole chunk of paragraph packed together the material from 3 different classes.
Right.
Yeah.
What about the probability metric a little bit above?
Let's see. So when you say above, let me know if you see it so I can stop.
Down a little bit. Right there.
Oh, the probability metric that an ith image belongs to class 1. Oh, yeah, don't get fooled by this word metric. It's just referring to the probability, the numerical number of this outcome. So it's really referring to this pi here.
Oh, okay.
Yeah. It just says that you can very well change this word to the outcome of this formula, which is really just pi. So it's a probability. A probability is essentially a fraction between 0 and 1. So when you do your undergrad, you can take this course called probability theory. Now, of course, the undergrad probability theory and the graduate level probability theory are 2 completely different things. So definitely start with the first one. And they're going to define all of this stuff. So there's this field called the measure theory. Measure theory is super complex and highly theoretical, especially at undergraduate level. So my recommendation is to take it slow and then think about in terms of human sense. You should, like if you toss a coin, the probability that it shows up head and probability shows up tail should sum up together to be 100%.
Right.
So think in terms of like from that perspective, it will make your life easier. So the same thing here, it's a probability. So it means it's a number and it's a fraction. It's going to be between 0 and 1.
Right. What is the P in the very beginning, the bolded one?
This P means it's a distribution. This P, it's a number. Okay. I actually, I think I actually did this one problem in Columbia when I was a grad student. I actually wrote this wrong. So I actually had this a very clear memory of what's going on. So when people write this, and then when people write this, sometimes they even write like something like this. Or sometimes people just write a P. This is a number, like an actual number, like 0.4. And that's it. It can't change today, it can't change tomorrow. It's just one number, it's a fixed constant. When people write this, they mean a probability distribution. So this is a distribution.
So one's a variable, one's a function.
Correct, yes.
Is there like a specific formula for the distribution or is it subject to change?
Yes, so there are a list of distributions. So there's a course that when I was at Columbia, I teach undergrad this course. It's called StatLect, statlect.com. StatLect. Just think of a statistic lecture, right? StatLect. This is a good website because it lists out all of the probability distributions. So you go to this website, right? Statlect.com, and you scroll down. There's this thing called a probability distribution. So you click on that, and then there's a list of them. So Bernoulli is the easiest one. It's a coin toss. You can read off this. This is a very technical. So at your level, you should be able to read off this and kind of understand and figure out what this means. Because there's no class before this class. You go to undergrad, you say, hey, I'm going to be a math major, or I'm going to be a stats major, computer science major. That's it. This is going to be the first class you take. So other than lecture.
And then computer science, so that's something I'm hoping for.
Yeah, in computer science, you're going to have to take this class. You don't have to take that many of this class. You just take this class once.
I'm looking forward to it so far. I'm looking forward to it so far. I haven't taken it.
That's great. Yeah, that's great. Yeah, so there are many distributions. Bernoulli is one of them. You can scroll down. You can show the derivations. There's some derivations here. this one is not that hard. There are hard ones. This moment function, this is a little bit hard. Characteristic, I don't think anyone's working on characteristic because this is letter I here. That letter I means it's an irrational number. Okay, like you're not even in this world. Like you're in like hyper I don't know what you call it, like kind of like a magical world.
Like
You're not in this
imaginary
world.
number?
In this world, yeah, the irrational number is defined as square root of -1.
Yeah,
Right. So it's not in this world. In this world, there's no square root of -1.
I had to do a presentation for my math class about the imaginary number, so I have a very vivid memory of it.
Yeah. Yeah. Exactly. Yeah. So in okay, unless you want to be a mathematician, I don't discourage people to do that, right? Of course, you have to care about this. But in this world, right, in this universe, in this world, whenever there's like there's cars, there's food, like normal day-to-day life, okay, the square root of -1 is not a thing. You can kind of
Right.
pretend that's non-existent.
It got introduced to us as the one thing you'd probably never use in this class. So
Yeah. 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 So kind of just like you keep it on a first name basis. Most statisticians keep on a first name basis. It might be a little bit helpful if you're doing super theoretical stuff. But based on my time at Columbia, I haven't really heard anybody doing research in this field. To be honest, so most likely people work on MGF. People work on something else. The first expectation and variance. This is probably too simple. Everybody know that. If there's any research, it's probably going to be MGF, moment generating function. And this is just one distribution. There's like other distributions. Yeah, binomial, that's another one. I don't know if you know this. Binomial is kind of like have you heard of the Pascal triangle?
yeah, it was in my final. It was yes, yeah.
So basically, it's basically this thing.
Yep.
Yeah. And then there's also something else called geometric. I haven't heard of. It's one of those things that's a little bit. I think you can. I think in some strange situation you might encounter this event. It's basically like it's kind of like a Bernoulli distribution and another Bernoulli distribution together, kind of like a sequence of Bernoulli distribution. That's essentially a geometric series. That's
Right.
basically how it's defined. It's kind of like a sequence of independent Bernoulli random variable. So that's kind of like it's kind of like you toss a coin, and then the next experiment is completely independent. You toss another coin, something like that.
Got it.
Yeah.
So,
Yeah.
a sequence of Bernoulli variables.
Yeah, I'll send you this. This is I mean, obviously you don't have to know it for this course. But if you're interested, check out this website. This website helped me a lot for my own study when I'm going through this course myself. So it shows you all derivations. There are of course some of the harder ones. Normal distribution, it's easy to understand, but it's actually pretty hard to derive. So it's literally just bell-shaped curve. But the formula looks something like this. Whereas the x, in this case, this is a standard normal. So the average is 0 and the standard deviation is 1. In general case, you're probably going to see something like this. So there's a mu here, that's the average, and a sigma, that's a standard deviation. So you always have these two parameters for normal distribution.
I have one question about sigma. Is the lowercase sigma and the uppercase sigma the same? No?
Lowercase. Oh, you mean like this thing and this thing, right?
Yes.
Oh, so this is summation. So if you do this, let's say I, this means 1 plus 2 plus da da da. Let's say this is I to n. I equals to 1 to n, and then this is a plus n. So that's how this is defined. This
Right.
sigma is just a letter for whatever number that you want to call. In this case, we call it well, the variance is sigma square, so the standard deviation is sigma.
Right. I'm not familiar with the term variance.
Variance is you can kind of think like this. A variance of a variable x is defined as, well, there's so many ways to define it, but the easiest one is something like this: 1/n summation I xi minus average. I guess I say x bar, something like this. That's probably the easiest version I can show you. When you get to the next level, there's going to be like a -1 here on the bottom, and then people do like all weird things with it. And another version of definition is this, which you probably won't be able to understand right now, but I'll tell you anyway. It's the expectation of x squared minus expectation of x parenthesis square. This is square. So this first square is inside the parenthesis. The second square is outside of the parenthesis. So that's another definition. These two definitions should be able to give you the same number. In a data set, these two equations should be able to give you the same number.
So expectation means what exactly?
Expectation means average. So expectation of x is defined as average. So you can think of as depends on how it's defined. Empirically, you can just think of it as everything add together and divided by n. N is a sample size. So you can think like this: x1 plus x2 plus plus xn. In reality, you're gonna have to work out the distribution function. So you're gonna have to do something like you're gonna have to look at the actual distribution. If it's a coin toss, probability of x equals to 1, it's 50%, and the probability x equals to 0 is 50%, because it's a coin toss, right? Heads 50%, tail 50%. So this is gonna give you expectation of x, and this is gonna give you 1 times half plus 0 times half. 0 goes away, then this is going to give you only half. So the expectation of this is called a Bernoulli distribution or Bernoulli random variable is going to be exactly 0.5, like this. So in reality, you're going to have to go through this formula to figure out the expectation. If I give you a probability distribution, you're going to have to do this way. But if it's in data science, I give you data, then you do the first way. You add everything together divided by n.
Got it. So everything added then divided by n.
Yeah. Notice that in reality, these two numbers may not equal to each other, right? If I toss 10 coins, it's not exactly the first 5 times is heads and the next 5 times is tail. It goes by chance, right?
Yeah.
So if you work out the first formula in an experiment, it may or may not be 0.5. So in other words, this is the theoretical average. This is theoretical average. Make sense?
Yes. Yeah.
Yeah.
Right. Yeah. That's really interesting. I didn't know about any of this.
Yeah, in high school, they typically don't teach this kind of stuff because it touches upon a lot of the mathematical idea that's not taught yet. Because in high school, probably the most advanced students will probably get past all the APs, and that's probably about it.
Yeah,
So,
I've only taken pre-calculus so far. I'm taking
Right.
calculus AB next year.
Right, exactly. So that's not going to be sufficient knowledge pool for you to fully absorb what all this is. I mean, someone can explain to you, but A, first of all, you need to find who that person is, and B, like you need to patiently sit down to make some derivations yourself before you can fully understand it. When it comes to this kind of stuff, memory is not going to be enough. Like you need a lot of practice, and you need to like the best students that I know, that I've seen so far are the students who are able to do the derivation, you patiently sit down and do the derivation, and I also recover all these work in using computer programming. So the best students should be able to do both. Like you should be able to derive it, and then you should also be able to write a program to demonstrate what this idea is. I'll give you an example. Let's say you toss a coin, right? Theoretically, you work it out according to the formula, it's a 50%. But you toss 10 coins, of course, it's not going to be the first 5 is heads, the last 5 is tail. So you should be able to show that if you toss 10 coins, maybe the average is about 40%. But then if you toss 100 coins, you should be able to get to 48%. And then if you toss 1,000 coins, then it's probably going to get to around 50%. Like that, you can show it. And
Show it.
yeah, that's a yeah.
Wait, so how would you show it? Like,
oh, it's in this case, it's kind of like an easy example. So what you do is you is this connected, or let me go to my Python. All right, so let's say down here, right? You need this library called random. So what I would recommend is this: import random, and then you can say random dot what is it, rand? Random integer, I believe, and then you know what? Let me get this. How to get the? It's you need a Bernoulli or binomial distribution Python. I forgot which library it is, but you should be able to get this library out. You should be able to do this. So this is gonna be SciPy. So stats binomial. You should just be able to load this up. Yeah, this is it. Yeah, so just run that, and then here I'll show you this. There. All right. Okay. So let's see. All I gotta do is copy, or obviously look at the library, right? And then so you say import library. All right. Cool. And then you have binom, and then all you gotta do is you need this thing. So you need to define n and p. So what is n? N is 5, p is 0.4. Well, you don't have to have 5 and 0. I mean, you can, but like you can do let's see. I want to have MP. So let's see. If I do n is 10 and p is 0.5, does that work? Array of 5.
what does
That doesn't quite make any sense.
you and Kurt mean? In
These are the moments. So mean is the first moment, variance is the second moment, and this is skewness, and this is kurtosis. So these are the third moment and the fourth moment. So if you Google it, it will tell you. So binomial distribution, Wikipedia. So you go to Wikipedia, and then it will tell you the mean, the variance, and the skewness, and the kurtosis. So these are different moments of the distribution. Yeah. And I believe this function should be able to just, if you specify this, it will tell you what these things are, and then you should be able to plot it. Let's see if we can plot it. Just directly plot them. N is not defined. All right, so N is 5, P is 0.4. It'll probably give you like
deleted import.
oh, okay, I did not do this one. Oh, I think I need to put them together. There. It just the binomial is discrete. It can take values 0, 1, 2, 3, or 4, but it still falls under a bell-shaped curve. So to prove that idea to you, all I gotta do is I change the n to a larger number. Let's say 50. Then it's kind of like a bell-shaped curve. I can change it even to an even larger number. Let's say 500. Then it should probably look like a bell-shaped curve. And this is a kind of leaning towards the left-hand side a little bit. You probably won't be able to see it, but if I do 1, you probably be able to see it a little bit. Oh, it just lean towards 50. Okay, I guess that's not. So typically you do 50%, so then it's a little bit equally distributed. But if you do like a 0.1 or 0.01, it will just lean to one side. So you won't even touch upon 250, 260, 270. You will lean to a small number. Like it's going to be a number from 0 to 500, and it's leaning to the left-hand side. So if I run this, I bet it will be like 3, 4, 5, something like that. Yeah.
Right.
So you won't even touch upon 400, 500. You won't even touch it. Unless this is 0.5, then it's kind of like even out. Like you touch upon 0, 1, 2, 3, 4. You also touch upon 300, 400, 500.
Got it. And the could you define the N and P?
Yes.
Like-
so N is technically speaking, N is support. N is the number, or should I say integers, that this distribution is allowed to accept. And P is kind of like P. Well, P is a probability, so how much it leans towards. If you say 0.5, then the weight of the distribution is essentially in the center of 0 to 500.
Mhm.
And 0 to 500, what is the center? It's 250. So the most of the observation falls in 250. But if I do 0.9, then it's leaning towards the right-hand side. So you're gonna see something like 400, 450, but you're not gonna see 200 or 100, right? So I'll run this, and I'll run this. Then you'll see like 400, 450 something. You're not gonna see like ones or twos or 100 or 200, because the weight is now leaning towards the right.
Right.
Yeah.
Okay, yeah, that makes sense.
Yeah.
Another thing, how do you remember most of this other than just practicing over and over again?
How do you memorize what?
How do you remember code like this? Because I have to take a Java certification somewhat soon, and I only have like a beginner-ish knowledge of the programming language, and you're clearly very experienced in remembering all of these sections of code. How would you recommend remembering things like this?
Oh, what I do is there's a smart way and there's a dumb way, and I've done both, and I'll tell you both. So the smart way is you kind of create a story for yourself, and you memorize the story instead of memorizing the code. So that's a smart way. So story is kind of like, hey, I always write out a story. I didn't do it like this. I didn't do it here, but if you look at my code, it's always a story. Here, I'll show you. So let's say you go to docs and then reference. I almost always have a story. Let's say CNN, one more on CNN. I usually have a story. Usually start with some sort of data, and then I kind of tell myself what I want to do. And then there's a research question. There's some notes, and then I plot some pictures, and then I tell a story, and then I say introduction, and then I say conclusion later. So I memorize a story first. Story, you can kind of memorize it. Usually it's with some sort of graph or even better animations, right? And then once I know the story, then I kind of link each particular story with the code. So I don't memorize the code directly. I memorize the story first. Now, of course, this kind of takes a little bit of effort because not everyone thinks of a story the same level of interest. Like I could be looking at this graph and I'd be like, okay, this is interesting. Somebody else look at this graph and they'd be like, what am I looking at? This seems very boring. That could happen. So it's up to you to somehow create a story for yourself that's interesting. And you memorize the story first. So that's a smart way. The dumb way is exactly what I did here. The dumb way is everything that you've ever found, put in a nice document that you can memorize, save it somewhere. And then you come back to it very frequently too. And then you trust that the more frequent that you come back, then the better that you're gonna memorize. But that's a dumb way. Then what that means is you're gonna have to come back frequently, like 10, 20 times. I would still recommend the first way, but the first way does take a little bit of effort.
So when creating a story, do you create like an actual storyline, or like when you're talking about Python rather than in terms of data, how would you memorize like aspects of the language?
I recall the story. So I'll give you an example. Let's say max pooling. You haven't heard of it, we haven't talked about it, you don't know what it is, right? So then students can ask me, oh, what's max pooling? It seems interesting. Can you explain to me? Maybe I memorize the syntax, maybe I don't. But I don't need to memorize the syntax. I just need to know where it's coming from in the big picture. And I memorize that big picture. And now in my head, I have like a bunch of different, like each data science pipeline, I try to memorize a picture. And the picture tells me where things are. And then once I locate what that is, I can kind of recall the syntax. So that's how I did it. It's not like I memorized each line of this. You ask me what's max pooling. Oh yeah, MAXPOOLN. It's not that. It's not that at all. I try to memorize the story first. I kind of know, okay, the student's kind of asking something about this, and then this thing is moving. Okay, max pooling. Okay, that's where the syntax is. Maybe it's usually a graph, right? So maybe I should add a 2D in there. So that's how I know this function is max pooling 2D. So I always try to memorize the story first. Does that kind of make sense?
It does, but so a story could be if you're going through like specific things in syntax that can't happen and won't allow the code to compile. How would you create a story about that?
Wait, what do you mean it won't compile?
Like many of the questions, I'm taking the 1Z0-811 certification exam through Oracle. And most of the questions are asking if